Okay, so this is objective 6.4b. The topic today is solving exponential equations using log properties. It's an intermediate level problems. A little more complicated than yesterday, require a little more algebra and a little more use of your log properties. Okay, so the essential question is, how do you solve these exponential equations using log properties to find exact solutions and approximate solutions? Okay, so just remember that when you're solving an exponential equation, like for example, if I were to give you 2 to the x equals 8, you don't need log properties to solve that equation, because you can make 8, you can rewrite 8 as a base 2 exponent. So 2 to the x equals 2 cubed, and therefore x equals 3. Now remember that a logarithm is an exponent, and so that's why when we're given problems like example A or example B, because we can't make those numbers into the same base, we have to use the logarithms, which are the exponents, to help us to solve these equations. So we have to use the log properties. So some reminders. If you're going to use the log property, these conditions must exist. The base of the log has to be positive. The m and the n, the arguments also must be greater than 0. So no negatives, no zeros. And the base of your log cannot be 1. And the base of your exponent cannot be 1 either. So here are your log properties. We've talked about them many times. And so there you have them again, so that they are useful and they're right on your note page. Something that I do want to mention today, if we're given two numbers, our m and n, if our two numbers that are going to become our arguments are positive, then we can take the log base b of m equals the log base b of n. We can just make them a logarithms. Today we'll do the log of m equals the log of n, because our instructions say to use the common log to solve. And so we are going to use the log of m equals the log of n to help us solve these equations. My preference is usually the natural log, just because it's faster to write natural log than it is log. But when you're told to use the common log, you use the common log. Okay, before we get started on these first problems, because these first problems ask you to simplify these fractions, remember that it's always your job to simplify a fraction. So if I were to give you the fraction 64/48, and I said, and you gave me that as your answer, I would probably mark it off a couple of points, or mark it wrong, because hello, you're a pre-calculus student. You should be simplifying your answer. So you could take that all the way down to, let's see, I could reduce that by 8, so that would be 8/6. Can reduce that down again by 2, and that would be 4/3, right? So it's your job to simplify fractions. It's always your job to simplify fractions. So let us do that first. So we're just going to work on a more complex level than, say, somebody who's in a 5th grade class simplifying a fraction. So here it says simplify the log expression. So there's a single log in the numerator and a single log in the denominator, using the log properties to condense. Excuse me, and you'll notice that here I have a log base tens. Okay, so your homework, or when you're doing your problems today, when you finally isolate your x, it's going to say x equals this complex looking fraction, and it's your job to simplify it. So we're going to use the properties to condense these fractions. So the first thing you're going to do here is, notice you got the log of 2 minus 2 log of 3 over 2 log 2 plus log 3. Well, you can't combine logs until they don't have numbers in front of them. So I would suggest first thing we do is power up our powers. That's part of our condensing properties. And so that would be the log of 2. And then maybe you're going to go plus the log of 3 to the negative 2. And that's okay, we can do that. Over the log of 2 squared plus the log of 3. So we powered up in those situations. And I did power up and make an addition statement so that I can combine using this property here, but you didn't have to power up the -2 in this situation. You could have just powered up the 2 and left it as subtraction. It'd still be the same process. So let's simplify that. That would be this here. This is a log of 3 to the -2 is the same as the log of 1/9, right? Because that's 1 over 3 squared. That's what log of 3 to the -2 means. So I'm just going to convert that there, and I think I'll also do that down here. 4 squared, 2 squared is 4. So I'm just simplifying as I go. So in my numerator now, what I have is the sum of logs. So to condense them to one log, I would do the log of 2 times 1/9. So that condenses my numerator over the log of 4 times 3. So condensing. And then I can simplify, just simplify. So that would be the log of 2/9 over the log of 12. And that is a simplified. That's simplified. You get a log in the numerator divided by a log in the denominator. Now something you could do to check your work is to just go into your graphing calculator, your scientific calculator, whatever calculator you're using, and just plug the original form of the fraction and the final form of the fraction into your calculator. And if they equal the same thing, you've done a pretty good job of simplifying. All right, let's try this next one. So here we have 2 log 1/5 plus 3 log 1/3 over negative log 1/5, excuse me, plus 2 log 1/3. So first thing you're going to do here, again, you can't condense the logs until the powers are in their powered up position. And so we're going to power up. And so that takes us to the log of 1/5 squared plus the log of 1/3 cubed over the log of 1/5 to the -1, because that is a -1, plus the log of 1/3 squared. And if you wanted to, you could simplify here in this position. So 1/5 squared is the same as 1/25. 1/3 cubed is 1/27. 1/5 to the -1 is the same as 5. And if you're wondering how I knew that, well, if I want to make that a positive fraction or a positive exponent, I have to flip the values. So 1/5 to the -1 is the same as 5 to the +1. They are the same thing. All right, and then 1/3 squared would be 1/9. All right, so we've simplified our powers there. Now we can condense, and again, because I've changed these both to addition statements, well, they were addition statements to begin with, I'm going to multiply the arguments to condense to a single log in the top. So that would be 1/25 times 1/27 over the log of 5 times 1/9. And then finish that out. That would be the log of 1 over 675 over the log of 5/9. So if you're wondering if you know how to do this, I'll give you a problem here. No, I'm not going to give you a problem. You make up your own. I made these problems up. Make up your own. Press pause, make up your own, and then simplify it to make sure you can go through the process. Use your calculator to take the original fraction that you wrote and plug it in. Take your simplified version, plug it in, and if they equal the same thing, then you've got it. You've got it. So press pause and do that if you feel like you need to practice that before you move on. Okay, so I'm going to assume you pressed pause and you did what you needed to do, or you were ready to move on. So example 2 says find the exact solution using common logarithms. Okay, so you have to use the log of m equals the log of n. You're going to have to use common log. Find 2 decimal approximations. Okay, so here we have 2 to the 6x minus 3 equals 6 to the x power. Okay. So I can't make 6 into a base 2, so I'm going to have to convert these to logarithms so that I can change them and solve them. So I am going to take the log And I can do this because 2 and 6 are both greater than 0, so I can take the log of 2 and I can take the log of 6. So the log of 2 to the 6x minus 3 equals the log of 6 to the x. All right, so now there are logarithms. Now I can try to solve for x. So I just use this property here. If m equals n, then the log of m equals the log of n. All right, next thing I'm going to do, I want to get those x's out of the power position so that I can start to try to isolate the x from everything else. And now I'm going to use some algebra skills. Well, not now. Let me power down first. Or let me use a log property. So the log of a power is equal to the power, which is 6x minus 3, and that's a quantity, so let's put parentheses around it, times the log. So the log of a power equals a power times the log. The log of a power x times the log of 6. The log of x times the log of 6. Okay, so we used, I'm going to go back up here. This was property 8, and this one's property 7. I just like to call them those properties. So first I used property 8, and then I used property 7 to power down. Now I need to employ my algebra skills. Because I've got an x in a set of parentheses, I need to get it out of there. So now I'm going to distribute. You know what I think? I think I'm going to color code here, which is something I probably should have done at the beginning. So let me do, oh man, today is not my day. I've made this video like 3 times already, and I'll be almost done with the video and something will shut down. It's driving me bananas. So hopefully I can finish this before it dies. So now I'm going to distribute. So I'm going to use my blue pen to do that distribution. So it's going to be 6x times the log of 2 minus 3 times the log of 2. Because remember, the log of 2 is a number. It represents an exponent. It's a number, okay? Equals x times the log of 6. So all I did there was I distributed. I use a distributive property to get the x on the left out of the parentheses. Now my job is to solve for x, but I have 2 x's. I got one on the left and one on the right. So typically, in algebra, we put our x's on the same side of the equation. So what am I going to do? I am going to add x times the log of 6 to this side of the equation, and I guess I'll take this number 3 times the log of 2 and put it on that side of the equation because it doesn't have an x in it. So here's what we got now. 6x times the log of 2 plus x times the log of 6 equals 3 times the log of 2. Okay, so I've got my x's on the left. So the next thing you typically do is combine your like terms. But these are not like logs. So I can't actually add 6x plus x because they're not multiplied by the same number. And the log of 2 and the log of 6 are different numbers. So I'm going to factor out the x. I'll go back to my blue pen here. I'm going to factor out the x. So that leaves me with x times 6 log of 2, 6 times the log of 2, plus the log of 6 equals 3 times the log of 2. Okay, so what did I do there? I just factored out the x. Because what I want to do is isolate the x, and I couldn't combine the terms with x's, so I had to factor it out, divide it out of those 2 terms. Now, what am I going to do in this situation? I want to isolate x, so I'm going to divide both sides by 6 plus the log of 2 plus the log of 6. Okay, and that'll allow me to cancel and cancel. So I'm isolating x at this point. So x equals, so here's what I have. 3 log 2 over 6 log 2 plus the log of 6. And 3 log 2 is probably a pretty crazy number. Log of 8. It's some weird number. I don't know exactly what it is. It's a decimal. Okay, so I can't simplify the numerator and denominator, like cancel anything. So I just need to put this fraction in simplest form. So what would I do at this point? I would power up the 3 and I would power up the 6 so that I could condense this. So this would be the log of 8. Oh, I'm sorry. I'm doing math in my head. The log of 2 cubed over the log of 2 to the 6th power plus the log of 6, and then continue to condense. Maybe I'll write that as 2 to the 8th now, or log of 8 now, and 2 to the 6th is 64. Okay, so in simplest form here, we have the log of 8 over the log of 64 times 6. Oh my gosh. So 64 times 6. Is that supposed to be a minus? Oh my gosh. Let me go back and make a quick change here. These are supposed to be subtractions. I get to that last step and I'm like, I pretty much remember that I was supposed to be dividing those two. That was a minus, not a plus. Okay. It should have been subtraction right there. Oh my goodness. I apologize. Please go back and fix that. All right. So let me continue to simplify this. Now that we're bringing it back, I want to simplify that fraction there because I actually can divide 2 into both of those. And so that would be 32 thirds. And so my final answer here in exact form would be the log of 8 over the log of 32 thirds. And then I'm going to plug this into my calculator. I would go to the other screen, but every time I try to go to decimals to show something, it shuts my video down. And this is my third time, like I mentioned, making this video. So I'm just going to do it with my graphing calculator here. And I'm sorry you can't see it. So I'm doing the log of 8, closing my parentheses, divided by the log of 32 divided by 3, close the parentheses. And I get an approximate 0.878. So we're going to round that to 0.88. And that is the solution. Now, how do I know it's correct? Well, I could plug it in. So I could go 2 to the 6 times 0.88 minus 3. That should approximately equal pretty close 6 to the 0.88. In fact, if you were to go to 0.8785, which is to 4 decimal places, and you were to use that number plugged in here and here, you would see that this answer is a very good answer. And it made the equation true. So your solutions here, exact, 2 decimal places. Okay, so let's try another one. Here we have a 3 to a power equals a 2 to a power. We certainly can't make a 3 a base 2. So again, we're going to go through the process of turning these into logarithms. And since 3 and 2 are both greater than 0, I can take the logs of 3 and the log of 2. So the log of 3 to the x minus 4 equals the log of 2 to the 3 minus 3x. So again, we use that property. If 2 numbers are equal, then the logs of those numbers are equal. Then we're going to power down because we want to solve for x. So we've got to get the x out of that exponential position so that we can solve for it. So that would be x minus 4 times the log of 3 equals 3 minus 3x times the log of 2. And I don't know why I put parentheses around that. I didn't need to do that. All right, so power down. Next, we got to get those x's out of the parentheses. So we're going to have to distribute our values times our logs. So that would be x times the log of 3 minus 4 times the log of 3 equals 3 times the log of 2 minus 3x times the log of 2. Okay, so now the x's are out of the parentheses. So we're solving for x. So you know the next thing we do is move the x's to the same side of the equation. Anything that doesn't have an x to the other side of the equation. So I'm going to add 3x log 2. I'm going to be careful this time and put it over there. And I'll take this 4 log 3, this minus 4 log 3, and I'm going to add that to this side of the equation and rewrite. So we have x times the log of 3 plus 3x times the log of 2 equals 3 log of 2 plus 4 log of 3. All right, so x's are on the left, everything else is on the right. Well, terms with x's are on the left, terms without x's are on the right. Now, we can't combine these, we can't add these because they're not like logs, they're not like terms. So in order to isolate the x, you're going to have to factor it out or divide it out again. So x times the log of 3 plus 3 log of 2 is equal to 3 log of 2 plus 4 log of 3. Okay, so now the x has been isolated away from the log terms, so now we can, through division, so let's divide by log of 3 plus 3 log 2 on both sides. And cancel it on the left. And so we get x equals this really complicated but exact solution that we have to simplify because it's a fraction and it is our job to write our fractions in simplest form. All right, so first, think about it. You want to combine those logs, so you have a log in the top and a log in the bottom, but you got those numbers there. So you've got to power those numbers up. So let's push them up. So we get log of 2 cubed plus the log of 3 to the 4th over the log of 3 plus the log of 2 cubed. And no, you cannot cross simplify that. Okay? That's like saying, okay, I have 5 plus 7 over 3 plus 5, and if I reduce that, the answer is 7/3. It's not. That's 12/8. That is not 7/3. So you cannot just simplify a portion of a quantity in a numerator and a denominator. Be careful. All right, so we can simplify that. I'll grab my red pen. So 2 cubed is 8. 3 to the 4th is 81. 2 cubed is 8. Okay, so now we can condense these logs now that we have a log plus a log and a log plus a log. We can just say, okay, so that would be the log of their product, 8 times 81, over the log of 3 times, let's do it times there, multiplication, times 8. So let's finish that out. Let me get my calculator. 8 times 81. Yeah, that's 648. So that would be the log of 648 over the log of 24. Again, you can't simplify 648 over 24 because 648 is a part of the log and 24 is a part of a log. If I were actually to plug so this would be your exact answer. If I were to plug the log of 648, let me do this. The log of 648 into my calculator. The log of 648 is 2.81157506006. And the log of 24 is 1.308. So this is kind of like saying 2.811575006 over 1.380211242. That's what the numerator and the denominator equal. So I can't just come down here and go, okay, well, how can I simplify those two numbers? No, you can't. Okay, remember, you can't just separate numbers from logarithms. Okay, so I'm just going to plug into my calculator really quick the log of 648 divided by the log of 24. And just remember, when you're using your calculator, when you put in the log of 648, you need to close the parentheses on the outside of that 648 before you hit your division. Okay, and my solution here is 2.037, so 2.04 would be my solution. And then, of course, I could check that by plugging it in. 3 to the 2.0370. I would probably plug that number in to 4 decimal places because it'll give me a more accurate answer. But again, it said the instructions said to go to 2 decimal places, so But if you were to plug those two values into your calculator, then you'd see that they would equal the same thing to many, many decimal places before they changed. And so there are your solutions. And this is how you do today's assignment.